Okay, good morning. This is a review on systems. I want you to take a minute and complete 1 through 3 on your own so that when I do go over it, you know what I'm talking about. Just try your best. By now, you should know what you're doing. And then when you're ready, press play and try to do these along with me. Okay, so if you don't have the paper at home, this is what it looks like. Pause it, try to do the questions on a separate sheet if you don't have it. Okay, determine how many solutions exist for the following system. So we could put these both in slope-intercept form, graph them both, and then determine the solution. Or we could use substitution or elimination. I will do both. So, of the latter two. Y represents 3x plus 3. So every time I see a y, I'm not going to write y anymore. I'm going to use the quantity 3x plus 3. And I put the parentheses around it to help me, because sometimes if I have a negative, I need to remember to distribute the negative. And I'm going to get 3x minus 3 equals 2. The negatives and the positives cancel. And then we get a not true statement. So therefore, those 3 dots mean therefore, there is no solution. It's going to be parallel lines if you would have graphed them, and they'll never intersect, therefore they'll never have a solution. Okay, so your answer is A. If you put them in the form that there is on the bottom, standard form, in the top part you'd have to put 3 to the other side, and y is already positive. And you would have seen that negative and the positive became 0 plus 0 equals 5, and that is not true as well. All right, number 2. Anna burned 15 calories per minute running. So running is X. Okay. And 10 calories per minute hiking. So hiking is Y. She spent a total of 60 minutes running and hiking. And she burned 700 calories. So don't get intimidated when you see these word problems on Keystones or on tests or homework. They're just explaining the two equations. You can solve the system as you normally would. It said, how many minutes did she spend running? Well, if you look up here, it says running X minutes. So running is X. So we're trying to solve for X. So if you end up getting Y, that's fine. Just remember you got to plug it back in for X. It is already in standard form. Running, hiking is 60 minutes, 15 calories per minute, 10 calories per minute, 700 calories. So I like elimination. So what we're going to do is multiply the bottom equation. We're trying to solve for X. So I want to get rid of Y. It doesn't matter which one you get rid of. You can multiply by negative 15 or negative 10 to eliminate the Y. It doesn't matter, but I want to eliminate the Y so I can get X. Okay. Okay, so the top equation is going to stay the same. It's going to be 15x plus 10y is 700. The bottom equation is negative 10x minus 10y equals negative 600. When you put them together, this is going to become 5x plus 0 equals 100. So if I want to solve for x, good, I already have x by itself, and x would be 20. So she spent 20 minutes running. If you solve for y, you would have got 40, and you might have circled 40, but we have to remember, are we solving for y or are we solving for x? Okay, so be careful with that. A lot of students will get 40, and then they say that's their answer. Okay, use the graph to answer the following question. The solution to which system of equations has a y value of negative 2? So this is where I get my highlighter out that mom and dad gotcha, that you're actually going to use now. Okay, so I would take the highlighter and say, okay, on my y-axis, where am I at for negative 2? So here we are at the origin. Okay, it's hard to see, but these are the types of questions that might be under Keystone, so I want you prepared for them. Okay, so 1, 2. So we're at 2 here, -2. Okay, so which system of equations has a y value of -2? Well, if you look, this line is there, and this line is there. So we have to see what equations go with it. So this equation goes with that line, 3x minus y equals 2. And this equation goes with that line, y equals -x minus 2. So which one has those equations? I'm looking for a 3x. I see a 3x, I see a 3x, I see a 3x. This one does not have a 3x. Okay. Well, this one's not quite that one. Let's see. We have 3x minus y equals 2 for both of these. And do we have a, oh, this is the one. It's pretty tricky, okay? So we're getting some practice. Now let's talk about these equations, okay? If you were taking your Keystone and you were kind of stumped, is there anything you could do, okay? You could plug in numbers. You could plug in 10 to see what you get for y for both of them, okay? It might not be the best solution, but it could help you a little bit. If I put in 10 here, I get 50. If I put in 10 here, will I get 50? Okay, so you could try that. If I put in 20 here and I got 40, well, if I put in 20 here and 40 here, does it also give me the same answer? So you could plug in one number to figure out the other number and see if it works for the other equation. Here, you could use a graphing calculator if you put them both in slope-intercept form. Okay. And then maybe here, you know, you could say, are any of these even equations that are on here? So just ask yourself some logical questions to eliminate. We're going to keep practicing every week with Keystone questions. And let me know if you have any questions. We are going to hand these in for points too, so make sure you do that as well.